Welcome, everybody in the lecture hall. Welcome, everybody on Zoom, a lot at 9 a.m. Welcome, everybody watching us from the future. So we were in the middle of syntax, and we saw that the syntax, like CSV for tables, is not enough for denormalized data because we want tables in tables in tables. We want the data to nest. We want the ability to have extra attributes, missing attributes, heterogeneity, meaning multiple kinds of values in the same column. And so we saw that we have JSON and XML that can do exactly that, but for trees. And what I would like you to eventually see is that whenever you see some JSON or XML, you see a tree in there, in your mind. Because this is exactly what the computers will do when they parse the JSON and XML documents. And so I showed the JSON already to you. There are 6 building blocks, strings, numbers, booleans, null, and then objects and arrays. And you can just mix and match in the sense that within objects and arrays, you can nest any of these 6 building blocks further with arbitrary depth. All right, so now we are going to go into XML, if it lets me. Also quicker than in previous years, because in the textbook, there is a bit more detail, and also you can play and make yourself familiar with the syntax. So this is widely used because it's a bit older than JSON in terms of ecosystem, and so it's used by a lot of governments for electronic digital documents, for example, the taxes. When you have the bank statements that you can upload to the tax return websites at the end of the year, the barcode has actually XML inside that looks like this. So this is ech.ch is a government standard website where a lot of the XML schemas are in there. It's actually pretty good for looking at XML schemas examples. And as you can see on the slide, they have also a pretty good sense of humor when it comes to providing samples. All right, so this is XML. And I'm going to just drive you, just like JSON, through all of the building blocks. So the first building block gives the nickname to XML of tag soup. It's a soup of tags. And you can recognize these tags with the angle brackets like this. So this is a tag. And these are called elements, right? So more precisely, in an element, you have an opening tag and a closing tag, right? So you open the element, you close the element. And the way you close is this little slash in here, a little bit like in many countries, when you leave a city or you leave a town, then you see the name that is with some line crossing it, right? So this is the spirit. You open and you close. And you see I put the opening in blue and the closing tags in red. And what we call element is really the zone that this opening tag and this end tag delimit. Then we can have also empty elements that have nothing inside, right? So you open, then you close immediately. But there is a shortcut because we are computer scientists, we're a bit lazy. And so there's a shortcut for that. It's perfectly fine, of course, but you can also write it like this with the slash at the end. It's just a shortcut for an empty element. So far, so good? Okay. This is forbidden. You see what's happening here. We open currency, we open name, but we close currency first. That's not okay. You really have to, whatever you opened last, you need to close first, right? So since you opened name last, you would need to close name first and then currency. So it's not okay to do this. You see that they are basically intertwined here, and that's forbidden. So you can also kind of call it well parenthesized, even though it's not exactly the same, but that's the spirit. This is also forbidden. You cannot have a tag within a tag within a tag within a tag. I mean, we break a lot of rules with tables in tables and tables, but we cannot have a tag within a tag within a tag. That is not okay. And also not in the middle of these quotes like this. And I'll shortly come to what this means. So this is also forbidden. Okay, so speaking of which, this here is an attribute. You see, it's a key value pair. The key is right here. The pair is right here. And you can have them in any opening element tag. You can even have multiple of them, multiple attributes. You can have single quotes or double quotes. It's entirely up to you. And it must be quoted, right? It has to have quotes. So for those of you who might be familiar with HTML, HTML is a cousin of XML. And in HTML, it's less strict. So in HTML pages, you might have attributes without any quotes, but not in XML. XML is very strict. Okay. This is forbidden to have twice the same name, twice the same attribute within the same element. If it's different elements, of course, it's okay, right? But in the same element, you cannot have twice the same attribute name, right? It's like in JSON objects where you cannot have multiple times the same keys. Here, you can also not have the same name twice. It's also forbidden to have the attributes in closing tags, right? They must be either in opening tag, right? Or in empty tag. Do I have an example with empty tag? Yes, right here. So they can also be in an empty tag. So opening tag or empty tag, but not in a closing tag like this. You see it's a closing tag because this is the opening tag, this is the closing tag. So you can't have this here. It should be here and not here. Okay, who is with me? Right, so these are the attributes. Do we have questions on Zoom? Or I see a little red. Oh, no, that's no question. All right. Then we have text. Text is basically in between elements, like everything marked in bold and blue here. This is text. And even between this, in this element, B and so on. There's not much to say about it, except that there is absolutely no notion of typing in there. So that's just the same as this. There's no notion of number or anything, right? It's just text, even though it looks like a number. For the types, we'll see in 2 weeks that we can validate them, and then we can say this is an integer, this is a double, this is a date. That was the question that somebody asked yesterday, but that we will see in 2 weeks, how we can actually do that. But in the XML syntax itself, there is no notion of type, there is just text, and that's it. Okay. Then we have comments. The comments look like this. So of course, it might be a bit strange compared to other languages that we have this angle bracket and an exclamation mark and then dash dash and then again dash dash and you close. This has historical reasons. Is that XML actually was invented as a simplification of a much more complex and earlier standard called SGML, that HTML actually also comes from. And SGML was extremely complex and had a lot of constructs. And since the goal of XML was to take a subset of it, then there are some remnants of SGML, right? So this is the reason it looks a bit weird. It comes from HTML, but that's how it is. That's an XML comment. All right. Very good. Then you might have, it's optional, but at the very beginning of the XML document, at the very top, you might have some declaration that says it's XML 1.0 or it's XML 1.1. You might also have a Unicode declaration, a declaration of the encoding, sorry, that says it's ASCII, it's UTF-8, it's UTF-16. That would be, I have an example of that in a few slides. That would also be in that text declaration. Maybe a few words on the version of XML. There's not a big difference between 1.0 and 1.1. The difference mainly comes down to some handling of the advanced Unicode characters that in XML 1.0, basically the specification is formulated as anything that is not, I always mix things up with this. So everything that is not explicitly forbidden is okay. And in XML 1.1, it switches to everything that is not explicitly allowed is forbidden, right? So it just became a bit more strict in terms of characters. For practical purposes, you don't really have to worry about the difference between the two, right? And you will see a lot of people still use XML 1.0. So we won't bother you with the differences with these two, except to know that it's not so much. Okay? So having said that, you might also see sometimes this, it's also optional. You might actually have seen doctype HTML. Whoever saw that? Doctype HTML, that's exactly what it is. It's the same thing. It's just a declaration that the top level element is called country. And doctype.html means the top level element is HTML in an HTML document. So this is where the doctype HTML comes from. This also has historical reasons. This is called DTD, the technology with this doctype. It used to have, it has schema validation abilities. It's able to validate some of the attribute values as types, but it's very rudimentary. And now we have newer generations of that. So this is why in this course, we will not even look at DTDs, except from telling you, you might see doctype in there. But we look at XML schema instead, which is a more modern and more powerful way of validating the data. All right, so now you know why doctype HTML. It's just a declaration that the top level element is called HTML. All right, which you might argue is not very useful because even if it's not there, you can see it, that the top level element here is called country or HTML. All right, then you remember that in JSON, you escape values in strings using the backslash, right? \n, \t, and then \u for the Unicode characters. Well, in XML, and again, that has to do with historical reasons, with HTML and so on, the way we escape is using an ampersand, like this, right? So you have an ampersand and then a semicolon. But there is good news, is that there's only 5 of them, and that's it. So it's pretty easy to learn. You have lower than, LT, greater than, GT, apostrophe, apos, quote for the double quotes, and amp for the ampersand. And that's it. And again, if you know HTML, you might know that in HTML there's more, but not in XML. In XML, there's really just these 5. You can declare more, but I'm not going to show you how. But it's possible. But there's only otherwise these 5. Do you know where ampersand comes from, the name? You know, it's this little symbol that actually likes the French ETH, right? The history of that is that the English alphabet used to have more than 26 letters, right? You had so you had this one. You had like some that remained in Icelandic. Do we have people from Iceland here? No, you also have some of these letters that are still present in Icelandic, like for th. But these letters disappeared with time. And now in English, we write th instead of this original symbol. But the ampersand was the last one that survived. And so at some point, we were left with 27 letters in the alphabet. And the name for this symbol was end, right? Because you use it to mean end. So when you recite the alphabet, it was at the end. A, B, C, D, E, blah, 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 X, Y, Z, end. And that sounded a bit not very nice, right? Especially to teach it at school. So then what the teachers started doing in that they finished like with X, Y, Z, end per se, end, meaning end all by itself, end per se, end. And when you say it very quickly, it's like X, Y, Z, end per se, end. And now you see ampersand, that's how actually it was born. It's actually from end per se, end. And you will still find some old 19th century alphabets for schools that still have it. All right, parentheses closed. It was just a fun fact about the origin of it. But now you will remember that this is how we escape characters in XML. We use the ampersand symbol. And now, and I just summarized that in just one slide, very quickly, just like when you have a double quote in the middle of a JSON string, you have to escape it with \quote. In CSV, when you have a quote, you have to double it. That's one of the ways to do it in the CSV standard. Well, it's similar in XML, that if you have an attribute that is double quoted, then you have to escape a double quote that is part of the value of the attribute, right? And the way you escape it, if you remember, is ampersand quote, right? Remember, that's it, ampersand quote. Likewise, if you have an attribute with single quotes, then you have to escape the apostrophe, right? And then these two symbols, lower than and ampersand, must always be escaped, always, no exception, right? So if it's in the middle of text, if it's in the value of an attribute, single quoted, double quoted, you always need to escape lower than and ampersand, right? You might argue that lower than doesn't make sense because in an attribute, for example, you would know that it's part of the attribute value, but it just confuses the parser. So this is the reason why there's this rule that you have to escape it always. So you see a document at the top where you see an attribute where double quoted, it's okay to have an apostrophe and greater than, but the other three must be escaped. In single quoted attributes, it's okay to have a double quote and greater than, but the others must be escaped. And then in the text, you can have greater than, apostrophe, and double quotes, but you have to escape lower than and the ampersand. Who is with me? Right? Okay, so now you know all the secrets of escaping. And by the way, I told you you can have an encoding declaration. That's an example. Encoding UTF-8, there you have it. That tells you information about the way it's encoding. It can be useful when you open the file and you want to read it. Okay, any questions so far? All right. So that was shorter than last year, so you can read the textbook for the rest. I just want to tell you one last thing about namespaces before we wrap it up with the connection with denormalization. Namespaces can be complex and scary. It actually does scare a lot of people. Actually, for some people, it's even a reason to use JSON instead of XML, except that now they do realize in JSON that maybe they should have had namespaces too, because it actually has some use in real life. So why do we have namespaces? Because people use JSON or XML or syntax for a lot of reasons, a lot of different reasons. There are people who use it for web pages, like HTML is a special case of XML for web pages. MathML is an XML dialect for mathematical formulas, like here the Schrödinger equation. MusicML is an XML dialect for music sheets, and then also the Swiss e-government standards and so on. They basically define some specific structures in XML. We'll see how in 2 weeks with the data types. But the thing is, because all of these people define things and then define structures and they define elements to do specific things, it can really quickly become a huge mess with everybody creating their element names. And in order to avoid that mess, we just tidy it up and we sort it nicely in namespaces. In fact, that's not really something new for you because you have that in any programming language too. In Python, you have modules. In Java, you have packages, right? So in order to put your functions also in packages like this. Well, we just call it namespace in that case. So you know that in Python, the name of a module is just a string, like pandas or numpy. In Java, it's a sequence of that is dot separated, right? So ch.ethg, typically the reverse domain dot and so on, right? Who is familiar with this? Python module, Java packages? I assume all of you, right? But here, XML is a standard by W3C. W3C is also the consortium that standardizes the web, HTTP, HTML. So how do we identify things in the W3C? Well, we love to identify everything with URIs. Why? It's the REST API and so on. So every resource is identified with a URI. And so this is the reason why they use also URIs to identify the namespaces.
We have a couple of questions on Zoom.
Oh, yes, go ahead.
Is it possible to escape the variable always, even if it's not strictly needed?
Oh, yes, absolutely. You're free to escape, to do extra escaping. That's absolutely fine.
And why don't we escape both less than and larger than? Because both have unique meaning.
Well, somehow the parser would be confused with less than because it could think that it's the start of a tag. But if we escape these and we just see a greater than, then there is no risk of confusion. Because imagine the parser is parsing stuff, and then in the middle of text, it sees a greater than, but there is no danger that it will confuse it for the starting of a tag, right? But there would have been danger for the lower than, then it wouldn't know. Does it make sense?
Yes, please.
Yeah? Is there another question? All right, so I'll continue. Very good. Feel free to ask questions, right? This is what we are here for. So, okay, so I told you this is W3C, and whenever we need to identify something, we use a URI. So I don't know if there are people who have cats and dogs in W3C. I don't know if they would use URIs to name their cats and their dogs, but that's a bit the spirit, right? So we use URIs for everything. And it can be confusing at first because most people, when they see a URI like that, they just want to type it in their address bar in the browser and go there, right? But this is not how it works, right? These are not meant to be typed in a browser or anything. These are just names. This is just some naming. And they just happen to use HTTP more out of habit. There is no reason actually why it's HTTP. Could be actually pretty much anything, and there are others. But it's just established itself like this, right? And typically, it's a convention that people would create namespaces with a domain they own. It's not something that is enforced, but it's something that is recommended, right? So you should create your namespaces with a domain that you own. That's, again, to handle a bit the mess and avoid the confusion. All right. And now for a concrete example, this is a namespace. That's the MathML namespace. It actually exists. And we are creating here a MathML document that is some equation. And the way we do that is that we say, this is my namespace that I have, and I associate it with a prefix, and I use the prefix everywhere to refer to the namespace, right? And so you see, and the little colon in the middle, so there's the prefix on the left, then the name on the right. So it means that all of these elements here, they are all, because of the prefix M, they are all in this namespace. Now, if it seems new, it's actually not new because you do the same thing when you import a module in Python. Remember, you do import pandas as PD, and then you use PD for the placeholder for pandas all the way, right? So that shouldn't be confusing. For whom is that clear? Right? Okay. So we associate a namespace with a prefix. It's called a binding, a prefix binding, and then we use the prefix everywhere. We can also do this, meaning we have a default namespace, and then it's not associated with any prefix, and that also is something you do in Python. When you say from pandas import star, then you're just importing everything, and you don't need any prefix anywhere, right? So you can also do this. This is called a default namespace. And you see the little difference is that the XMLNS here, without anything, it says that's the default namespace. If you have XMLNS colon M, then you're binding M to the namespace, right? This is a normal namespace binding, just like this in Python. So just like this in Python. And you have the default namespace that would be just like this in Python. And it's the same, right? In the end, just like in Python, it's the same to do it one way or the other. It's also the same. So this document and this document are semantically the same documents, right? This is MathML. Okay. Then you should not confuse this with no namespace at all. So the documents I showed you at first, they didn't have any namespaces. This is not the same document because in that case, we just have elements that are in the wild without any namespace, but here they are all in that namespace, right? So this is how it works. In fact, that also exists in programming languages, right? In Java, if you don't specify any package, then you're basically outside of anything, right? You just don't have any, it's the default package. So you also have that in programming languages, okay? But it's important to understand that the moment you have this default namespace declaration, everything that is not prefixed belongs to that namespace. That's what it does. Okay? Also, something that shouldn't surprise you, the prefix is totally irrelevant. Totally irrelevant. Just like in pandas, in Python, you can put whatever prefix you want, import pandas as P, PD, PNDS, or as the default, import star. It's all the same. You agree it's all the same, right? Doesn't matter. So it's the same here. In fact, I even saw some posts on social media, like how to confuse Python people with import pandas as NP and import numpy as PD and so on. Well, you can also do that. Okay, so the prefix is totally irrelevant. It's really the namespace and the name that matters. So the name of the elements in here, we call it the local name, just to clarify that it's not the full name. The full name would be the local name plus the namespace. So this is called the local name, this is called the prefix, and this is called the namespace. Okay, who is with me? Very good. So now everybody can create their namespaces for music, for the taxis, for everything. This is an example of mixing namespaces. This is an actual HTML page. You can take it and save it as a file and open it in your browser. It will actually work, and this is what it will show, right? It shows a beautiful formula for solving a second-degree polynomial equation. And you can see that what we do here, just like in Pandas, we would import both Pandas and NumPy. Here, we just say we have the HTML namespace. That's this namespace right here. And we have the mathml namespace right here. And we have these two prefixes, HTML and math. Then you know that everything marked in blue here with the HTML prefix, that's HTML. You know them, right? Head, title, body, H1P, this is typical HTML. And then we have the ones prefixed by math, which I marked in red. And here you recognize some mathematical stuff, right? Some fractions, some square roots, some power, sup, and so on. That basically gives you that formula. And in fact, you can absolutely do that. Within HTML, you can have mathml, you can have SVG, also scalable vector graphics, images in an SVG namespace, and the browser are able to actually process them and show them. So you see why namespaces are useful, right? Because you clearly know this is HTML and this is a mathematical formula. You have a question over there? Yeah, go ahead. Yes, you can do that. Absolutely. So to be clear, you could, for example, say that HTML is the default namespace. So in that case, you just remove this HTML right here. You just have XML and is equal to this, and then you don't have prefixes. But then you still need a prefix for math, right? Because you only have one default namespace. You can actually do that. People actually also do that a lot. I would say then it's a lot of a matter of convention and style, right? So what can and should be done and so on. I have a few words about this coming right up. Because you can do a lot of things. So let's say it's a continuation of the answer to your question. In fact, you can declare these namespaces everywhere. The problem is that nobody understands that. I mean, a computer would, but imagine as a human making sense of this, where you're basically defining foo, but then you're redefining foo there and so on. So even though you could, my recommendation is simple, do not ever do that. Plain and simple, do not do that. Put all your namespaces nicely at the top, like this. If you want to go extra alphabetically sorted and so on, that's also something that I like to do. And then it's clear, right? You have your namespaces, you have your prefixes, and you bind them. But avoid doing that sort of things because that's going to confuse people a lot. So what I recommend is sticking to 4 conventions. So you see convention number 1 on the top left is you have no namespaces at all. That can be useful if you're just playing around, right? Then convention number 2 is you use a default namespace. That is very useful if that's the only namespace you have, right? If that's the only thing that you have in your XML document, it makes perfect sense to have a default namespace. Or you can give it a prefix, right? So then you have one prefixed namespace, so that's number 3. Or you can have several prefix namespaces, you see alphabetically sorted, A, B, C, D. So that's the 4 that I recommend. So the answer to your question that you asked earlier is you could mix, of course, default namespaces and prefix namespaces, but again, this can create confusion. So if you have multiple namespaces, I do not recommend that you use a default namespace. Then I would recommend you give them all a prefix. Just like if you write a Python program that only uses pandas, then imports everything from pandas import star makes sense. But if you use 10 different libraries in Python and you import them all with star, then the code is going to be hard to read, right? So that's the spirit. So if you want to keep things easy to understand for people, then stick to these 4 conventions. Like these are the 4 recommended. Who is with me? Right? Okay, very good. So we will see, and again, that's in 2 weeks, that so namespaces allow us to nicely sort the elements. in 2 weeks, we will see how we can force structures. For example, when you have in this document right here, it's HTML. You know that in HTML, you cannot do what you want, right? You cannot put a title in the middle of the body and so on, right? You have to put them in a certain way. The title is in the head, H1 should be in the body, and so on, right? So there are a few rules. This is what we have schemas for. And we'll see that in 2 weeks, that you can build schemas that enable you to enforce a specific structure, namespace by namespace. Every namespace can specify the structure. And then you can also specify types. You can say this has to be an integer, this has to be a date, and so on, right? So great. So this is namespaces. Okay. Then I have a few more things to tell you before we go, before you go and before we wrap up. I recommend that right now, today, if you haven't already done that, go to itshop.ethz.ch, look up Oxygen XML editor, the latest version, and download it, because ETH was so kind as to pay for a license site-wide for people to use. This editor is very powerful. You can use it for the exercises. It tells you the well-formedness issues in XML, in JSON. You can open all kinds of data set in XML, JSON, YAML, JSON lines, and so on. You can also build your schemas with a lot of, auto-completion, and it can generate samples for a schema. It can tell you if a document is valid against a schema. You can even write some codes, but that we'll see at the end of the semester with the query languages. So not just for the course, but also for your projects, if you have projects later that involve syntax like this. Very convenient, right? And since ETH paid for it for you, you don't have to pay anything, right? So go there, download it, and use it in the exercises, right? It's a very good way to play around and make yourself familiar. Whenever you wonder, is that a load, is that not a load? Then you can just try it, and it will tell you. It's like in Matrix, there is a blue button and a red button that you have to pick from, and the blue button tells you whether it's well-formed, and the red button tells you whether it's valid against the schema. Okay? Nothing else happens with these buttons. Okay, so now I have a bit of time to wrap things up a little bit. So just like I showed you that when we have a table, we can represent it with a flat JSON object, remember? Well, we can do the same thing with XML, right? We could use XML in this way, saying that the record that is marked in red, so phone 800 John 1, can be expressed in the XML syntax like this, right? Who agrees? Right? Very good. And now that's the same thing that somebody mentioned yesterday, is that you have types right here, but not there. And indeed, if you just do that, you lose the type information, right? This is just text. But again, in 2 weeks, with schemas, you can actually also recreate a schema that enforces these types on XML, right? Yes?
Is there any reason why we use this form of expressing the data instead of using attributes?
Mm-hmm. So the question is, should I use elements or attributes? Right? That's also a good way to troll an XML forum, by the way. This is a regular question. So that's a very good question, perfectly valid to ask. So the short answer is you can do both. You can absolutely do both. In practice, I think that people like to use elements just because visually it's more appealing to as a human to see. But there is still a bit of a difference between the two, because the elements can nest. You can have an element in an element in an element, just like you can have an object in an array in an object. So if you would use attributes in XML, then you're stuck at that level, because in an attribute, you cannot further nest. Does it make sense? Right? So in that case, we could absolutely have attributes. But for the case like this, sorry, like this, I will go to it later, then the attributes no longer work for that. Do you agree? The attributes, okay, awesome. So very good question. You can do both. People debate about it. In practice, we do that a lot. What people also commonly do is that they hit some kind of compromise, in the sense that they will use elements for most of the for most of the attributes, and they will use an attribute for the attributes that are like IDs, right? A person ID, a product ID, then this they might put commonly in an attribute, right? It's more a matter of convention. There is something else that I will show you right away. It's that elements can repeat. It's perfectly fine to have multiple times the same elements in a hierarchy next to each other, and I will show you that it actually makes sense. Right. Did I answer your question? Yeah, all right, very good question. Now, that's one record. Then how do we deal with plenty of records? Well, in JSON, we just put one object per line, right? In XML, we don't really have the equivalent of XML lines. That doesn't really exist. We really have an XML document, and in an XML document, there is a golden rule that there must be exactly one top-level element, not 0, not 2, exactly one. That's the one you have in doc type. So then what we do is that, again, it's a convention. We typically take the plural form of the individual element, so that's sales, so sales with an S, and we just say sales is the top-level element right here, and then we have sale, 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 and so on, right? And you see, we repeat always the name, but that's perfectly fine because technically it's a hierarchy with the children, and it's perfectly fine to have multiple times the same name. So this is how the XML document would look like for the table on the left. For whom does that make sense? Right, very good. So the next step then is nestedness, because at that point we could use attributes, and attributes would also work just fine, right? Within sale. So product, price, customer, and quantity could be attributes in the sale elements. But if we have this, a table in a table in a table, in JSON we saw that we just put objects in arrays in objects in arrays in objects in arrays, right? Well, in XML we just nest elements. So it means that for these records, so in that case it's just one record, there could be more, but one record from that table with a nested table. So you see sales, sale, so the same thing, and so it closes here. So all of this corresponds to this record right here. Product and price are the easy ones, right? Product phone, price 800, it's right here. And then we have orders, right? Orders that correspond to this column. And then we nest. So we have the same convention, plural form, singular, right? Where you have inside orders, order, 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 just like in the British Parliament, right? So you have all of these nested elements, customer, quantity, and so on. And again, you can define a schema and enforce the types right here with a schema that we will see in 2 weeks. All right. One more thing I would like to say about XML is, so XML and JSON is actually pretty much the same thing, except for one thing. For data, you can use either. But there is one thing for which XML actually shines, and actually that's the historical use case, it's the publishing industry. It's when you store books, scientific papers, and so on, where you can see that within the text, you have tags. So you have a mixture of elements and text. If you know HTML, you know this is what happens there too. You have div, span, P for paragraph, then you have B for bold, I for italic, and so on. So of course, now there's also CSS that is used for the styles, but historically, you could format text in this way, right? So you can just have a mixture of text and elements. This is something where XML really shines for publishing documents. In JSON, you could, of course, hit it with a hammer and force it to go into JSON, but you would quickly notice that in JSON, it's much more difficult to map. So this is the one specific use case where XML stands out compared to JSON. But for this sort of things, JSON or XML is really the same, right? All right, so the publishing industry. And I also wanted to show you that XML and JSON are not the only syntaxes out there. There's more. One of them is called YAML. Whoever heard about this one? Right? So whenever something starts with YA, it means yet another, right? So YAML means yet another markup language. And you see that what makes it special is it's even simpler than JSON. You don't have curly braces, you don't have angle brackets. It's just indented just like Python. So you have here country, that's like the object keys, blah, blah, blah. Here you have nestedness with the indentation, so an object within an object. Here you would have an array, right, with the little bullet points. So basically, this gives you the same structure as a JSON document with dictionaries, lists, and so on. Who understands that syntax without further explanation? Right? Very intuitive, right? So I won't even go into it. Which brings us to two final questions. So for denormalized data sets, which is better? JSON is better, XML is better, CSV is better, both XML and JSON, but not CSV, or all three of them? So we have a huge majority. That's great. That's fantastic. Wow, okay. So yes, this is the idea. So CSV cannot nest, that's a technical fact. XML and JSON for data sets, it doesn't matter which one you use, depends on the specifics that you have. XML might be a bit older, so it means that there's maybe more tools and more standards. JSON is a bit younger, but really it's the same. And regarding the verbosity of the syntax, yes, the XML syntax is a bit more verbose, but we'll see when in 2 weeks when we look at schema validation and so on, that the verbosity is only in the syntax. Once you put it in memory, you start optimizing, right? And then you can even save it in other formats like Parquet and others. So you can really use both. All right. And we do have people who prefer JSON and people who prefer XML, and of course that's totally fine. Then it's also a bit of a matter of taste, right? But technically, XML and JSON are both very good choices. So that was my first question. And the other one is to make sure that the speed is okay. Okay, so it means that it was useful to shorten a little bit, because now we are back to the 80 to 99, and I see that I didn't shorten it too much, so you could still follow. All right, so I guess that's it. I can let you go with a few minutes ahead of time. Thank you very much, Dalia, for the moderation. Keep asking questions by email on the forum. Thank you very much. See you next week.